Welcome to Ask and Learn.
So here in this equation, we have f as a function of lambda. All right, so this is wavelength, the mass of the particle at rest, speed of light, Planck's constant, and wavelength. So really our variable is wavelength, or lambda. Okay, so the domain here, let's make this a little smaller to fit everything. The domain here is going to be x has to be positive, so x is going to have to be greater than 0. And why is that? Because wavelength has to be positive, because it's, measuring the wavelength. Okay, so there are no points of intersection, but we do have asymptotes. So vertical asymptote, we can see because of the lambda here, dividing by 0 can't do that. So vertical asymptote, we're going to say at lambda equals 0. Okay, and now we're going to find the horizontal asymptotes by looking as the limit. All right, so as the limit, as x approaches infinity of our function, so f of lambda, and we see that it's going to turn out to be m at rest, c squared. All right, so I'm sorry, my bad. So here it's not x, it's not our variable, it's lambda. All right, so here we have a horizontal asymptote at e equals m at rest, c squared. All right, and now we know that f of lambda is going to be decreasing on its domain. So it's decreasing. All right, so now if we look at the graph, right, this is lambda, and this is energy, or f of lambda. We know that we have an asymptote at lambda equals 0, which is here. And we know we have another asymptote at e equals m initial c squared. And now we don't know what that is, what this is exactly, because, for example, we know that c squared is a constant, speed of light squared, but the mass initially, we're going to have to, gain that in another way, but let's just say that it's somewhere around here. So let's say that this is E equals m at rest c squared. Right, so it's somewhere there. And we know that it's always decreasing. Our function is always decreasing over our domain. And it'll approach but not touch asymptotes. So we can see that this is an inverse relationship, and it's energy and wavelength are inversely proportional, meaning as energy, let's write this in blue, as energy increases, or as energy decreases, as wavelength increases.